Okay, this is a video of a tensile test of some 1-inch RAUPEX white UV shield pipe at the REHAU laboratory in Leesburg, Virginia. What we've got here is a piece of pipe 6 inches long, captured with the fittings connected inside what we call the tensile testing machine. What this machine is going to do is stretch the pipe at a fixed elongation rate of 2 inches per minute, as you can see in the upper right. And the machine is also then going to record how many pounds of force it takes to stretch the pipe at that rate, and it's going to show us the extension until the pipe breaks. So we're going to stretch this pipe until failure. Okay, go ahead, John. Okay, so the machine is on. What you can see is the bottom plate is fixed. The top plate is moving. The top plate is actually moving at 2 inches per minute away from the bottom plate. Now you can see this pipe sample is also put together with 1-inch EVERLOC fittings, male pipe thread fittings, and each of those fittings then is threaded into these adapters we fabricated to connect the pipe to the tensile testing machine. So the actual free length of pipe that's not captured inside the fittings is about 4 inches of free length of pipe in between the fittings. So as we measure our percentage elongation to break, we're going to be comparing against that 4 inches of free length of pipe. So here it goes. The machine's going at a steady rate, 2 inches per minute, and it'll apply whatever force it needs to, up to 5,000 pounds force, to stretch the pipe at that speed. You see right now it's taking over 1,000 pounds of force to move the pipe that fast. So that's half a ton of force with this 1-inch PEX pipe, and we've stretched about 2.5 inches so far. Now, when you do this kind of a testing with a PEXa pipe, it's interesting because as you stretch the pipe, some of the stretching or elongation is what they call plastic deformation, which means you're actually just stretching the pipe and it doesn't spring back. You just, change the shape of it, change the dimensions. But the rest of the elongation is what you call elastic deformation, which means the pipe does have some spring back to it. So we're going to stretch this pipe to failure, and then you're going to see the pipe will stretch back a little bit, but it's also going to stay mostly stretched to match the failure length. But this is going to take a few minutes because we're going to see really good elongation of this pipe before it breaks. Okay, we've just crossed a 4-inch extension mark, and considering there's 4 inches of pipe free to move between the fittings, that means we've doubled the length of the pipe so far. So that's what we'd call 100% elongation. Okay, in the lower left on the extension display, we can see that we're approaching 8 inches of extension. And considering the free length of our pipe was 4 inches to start with, and that means we've tripled its length, or 200% elongation. The peak force so far has been 1,037 pounds, but that may go up again as we continue stretching the pipe. You see there's no movement of the fittings. The sleeve is as it was when we put those together. And we will not expect to see any movement of the fitting. We'll expect to see that even a failure, that the pipe is still captured within the fittings. And we'll see a failure of pipe and not a failure of fittings. Okay, we're approaching 12 inches extension. So that means the original 4-inch sample of pipe is now 16 inches long between the fittings. This is really stretching. Okay, we've just crossed a 14-inch extension mark, which means our pipe is now 18 inches long. That represents 350% elongation, but no break yet. Okay, there, what we had was pipe failure. It was where the pipe goes into the fitting. John's going to take that fitting out so we can see the pipe is still inside the fitting, so the pipe did not pull out of the fitting at all. Thanks, John. And then you can see also how much the pipe did spring back, because from that fitting location the pipe sprung back about 3 or 4 inches, so that shows the what they call the elastic deformation of the pipe. The rest of the pipe, though, is still staying stretched, and that's the plastic deformation. You can see it's nice and straight. It's still a strong pipe staying up like that. Let's check our readings here. So we had almost 16 inches of extension with an original pipe length of 4 inches, so that means we ended up with 20 inches. That's representing over 400% elongation. And the force to do that was over 1,000 pounds, and that remained fairly constant throughout the whole test of the pipe. So there you see the properties of PEXa, and also it's a great demonstration of the EVERLOC fitting system in terms of its strength. You just can't pull it apart.